Okay, welcome everyone to this talk about the potential existential threat against C++. Let me just start with 2 words about me to give you my background. I've been doing software development professionally for a little over 30 years. Most of that has been C++. So that has been fun. I've really enjoyed it most of the time. I've also done work in other languages, including Rust, also for production. So what I'm trying to get across is that I'm not some sort of Rust undercover agent trying to bash C++. This comes from experience. The last 11 years has been at a company called Thales Norway, and we do secure communications. So for that time, I've tried to make as secure C++ code as possible, which is very hard at times. We are usually hiring. We're not hiring embedded people right now, but if you check back in a while, it might have changed. It usually does. So here's the link if you need it. I will try to publish the slides afterwards, so don't worry if you don't get this. So what is this threat? Well, we have a memory safety problem. There's been a lot of statistics and surveys about this. People can argue about the numbers and what sort of data that's relevant and so on, but you can have a look at this if you like. This percentage is typically for stuff that has a lot of C and C++ content. So have a look if you're interested. I won't argue statistics here. We can do that afterwards if you like. Little progress has been made on this. It's been known for quite a while, and in many ways, the language has not truly responded. It's been modernized generally, but there hasn't been much work done specifically to make it safer beyond that. And importantly, it's hard to see any detectable change of priorities. Speed still seems to be more important than safety, and many of the easy fixes are not made. So, are we behaving badly? Are we acting in a responsible manner? Well, are we fulfilling our responsibility to society? If you look at this from outside, you might be tempted to say no. And the dangerous thing about that is that irresponsible professions will eventually be regulated. And there are some signs that this might be starting to happen. Some of you have seen this. It's a report from November 22 by the NSA about software memory safety. And this caused quite a stir. You can have a little look at that if you like. So they basically want us to migrate away from C and C++ specifically. A while later, the Cybersecurity and Infrastructure Security Agency, quite a mouthful, published a report that backs this up, and they also got a lot of other organizations from around the world to co-sign this, to add weight to it. And then, in December of last year, the NSA came out with another report, which turns up the heat quite a bit. There's quite a lot of text on this, but this is a quote from the report, and what they want organizations to do is to write and publish a document with a strategy to move away from memory unsafe languages, basically. And, well, they urge us to do that. And they also want us to name an executive who shall be personally responsible for carrying out this strategy. Yeah, this is not vague. This is almost as close to regulation as you can get without actually doing it. And then there's a report from the White House a little after that again, which sort of backs it up, but it doesn't bring much new to the table, except that they want to make security measurable, which is interesting because you can build stuff on that. So what are the next logical steps? Well, governments could come with requirements. They could require us to make this plan and follow it. They could require us as suppliers to document the extent of unsafe languages in our products. If they put out tenders and we submit bids for that, They could penalize us if we use unsafe practices. You could possibly see accountability and liability if you have a security breach and that causes someone to lose money. You could be liable for that. Finally, prohibition. I don't think we will get there, but it's the end state. There was also this, which is a report from Google, which is quite interesting. It's a good read. I recommend you have a look at it if you are interested in this topic. This seems a bit like an answer to NSA's asking for a migration plan. And the strategy they seem to outline, or well, they're considering, actually, is to write new code in Rust, to rewrite high-risk components in Rust, and to try to make the remaining C++ code as safe as possible. It mentions Carbon, but that does not seem to be part of the strategy as of yet. That's not because they don't believe in Carbon, I'm sure, but it will take a while for Carbon to be ready, and they have stuff they have to fix now. They don't have the luxury of waiting for a new language. Other major players, like Microsoft, putting Rust in Windows, migrating .NET internals to Rust, as far as I can tell, and famously Linux has just adopted Rust as its second language. So you can try to draw some predictions from this. These are my personal ones. Yours might be different. But I think the era of memory unsafe languages is ending. It's not the end, but maybe the beginning of it. And I think that there will be no future popular languages that are not memory safe. I think that's done. So why can't we just make C++ memory safe? And what does memory safe mean anyway? Well, a good definition is surprisingly difficult. There is this paper that you can have a look at. It will take you deep down into computer science theory, which can be fun if you have the time and inclination. But it's hard. And most of us will get by with just an intuition about what isn't. That's what we usually do. And there are a few things that are obviously not memory safe. Read and write out of bounds. We've all done that. That usually goes under the heading spatial memory safety. Use auto-free, temporal memory safety. Using uninitialized values, initialization safety, a popular topic on conferences like this. Casting a pointer to the wrong type goes usually under the category type safety, and so on. Iterator invalidation, which is also an example of temporal memory safety. Data races, thread safety. We've probably all fallen into that trap as well, most of us. And then you have the big one, anything else that is undefined behavior. Undefined behavior can give you nasal demons, and nasal demons are not memory safe. So that's a big one. So what can we do with C++ to make it memory safe, or something close to it? Well, it requires a safe subset, somehow. So what has to go? I'll go through a few examples. But wait. That was silly. Yeah. We have to forbid pointer arithmetic, for one, fundamentally unsafe, and range checking for out of bounds. I skipped a bit faster because that's when this comes. Wait, we have range checking in C++, actually, even for the indexing operator. You just use this one. You define glib cxx assertions. So let's see a show of hands. How many of you already knew that? Okay. And how many of you use that in debug? Okay, so about 5. And how many of you use that in production? There's 1. Okay, good. That's it? Right. So what can we learn from that? Memory safety must be the default. If you make it opt-in, then people won't use it. Plain and simple. It needs to be opt-in. Opt-out means nobody uses it. I go into a bit more detail about things like that in my talk from last year, if you're interested. Temporal memory safety. We need to get rid of old school new and delete, obviously, but that doesn't pain anyone. We just use smart pointers instead. But it's not that simple. Here's some simple code using unique pointer. So we have a class A, which owns a B, so their lifetimes are the same. But then someone else needs to communicate with B at times. So class C has a pointer to B, a dependency. And if someone comes along and deletes A, then B goes with it. And if you still have the C, then it's left with a dangling reference. So storing references or pointers in members or globals is unsafe. You can always come up with examples that break everything. So what to do? Prohibiting that? Well, very difficult. It breaks everything. You could use a Rust borrow checker. Maybe the only current thing that works. You don't want to go to garbage collection. So this makes it very difficult to make the language safe. You could say, well, use shared pointer. But that has its drawbacks too. It's a bit slower, if that matters. But it also removes ownership semantics. It gets very hard to reason about the lifetime of things. You know, when does the B actually get destroyed? So it's not ideal. And it gets worse. Storing references or pointers in parameters or locals is also fundamentally unsafe. Simple example, you have a function that takes an A, and that happens to be in a different translation unit. You call the function to get a B from A, and then you call this whatever function on A, which happens to delete the B, and then you call the function on B, and boom, you have a use after free. And the problem here is that you store the reference locally for too long, and the language allows that. And there's nothing the compiler can do about this. Same thing almost, iterator invalidation. You get an iterator to the beginning of a vector, you push back, which means it can get reallocated, and then you dereference. Boom. Now, static analysis can detect some of this, but what if you pass this iterator to another translation unit? Then it can't. Very difficult to analyze. So iterators invite UB just as pointers do, and are also fundamentally unsafe. And to fix that, you probably need a new standard library. So for temporal safety, the problems tend to span translation units and makes them virtually undetectable by the compiler or static analysis without language changes or restrictions. So can we be memory safe? Well, it requires some very difficult things. We need a borrow checker of some sort, or we need to forbid references and pointers, which breaks everything. The iterators will have to go, because they are fundamentally unsafe. And we need to remove undefined behavior, which is all over the language and all over the standard library as well. So it doesn't help just to fix the language. The library needs replacement as well. And of course, thread primitives invite data races. So this is incredibly difficult. And all safety features must be on by default, or they will not be used, as we saw. And it's difficult to claim to be safe otherwise. So this will break all C++ code bases, and will in fact be like a new language. So what's happening with the standardization? Are there any improvements coming? Well, there is significant low-hanging fruit if you want to fix things. You could have spatial safety for containers. You could fix some important issues with optional and unique pointer. You could trap if someone tries to dereference one and it's not defined. It's not difficult. And the glib CXX assertions do that, so it's available. You could have guaranteed initialization of variables. So what's coming in 26? There is a paper that has been approved for initialization of local variables, which is great. It doesn't do anything for variables on the heap. it would be nice to fix that too, but this is a start. There is a studspan at coming, which is nice. Studspan did not have a safe way to index things. It was proposed, but it was voted out. Someone thought it was not important to have a safe API for studspan. I won't say publicly what I think about that. I can tell you over a beer. It's not something I want on tape. And then you have a fix for some UB in connection with infinite loops, which is nice, but it's not a big thing. And I may have missed something, but that seems to be about it. There are some other proposals. Bjarne Ståsup has a paper on using the CPP core guidelines to make some security profiles, but it seems to be not very concrete and actionable at this point. There's a lot of work left to be done, and if you want to make something usable out of this, I think you have to break basically everything. So I'm not sure if this is going to work. There's a paper on constrained numbers, which is cool. It's safe numerics, if you like, which can fix a number of problems, but that's also opt-in. And not much else that I could see on spatial or temporal memory safety. I'd like to hear it if you see something I haven't, and I haven't checked back in a few months, so there might be more, but I think we need to see more soon. And if I could make a wish, what I would like to see is a coordinated effort for security improvements, and that we make safety more important. It is the most important thing, in my opinion, at this point. And the willingness to trade performance for safety. Modern compilers are incredibly good at optimizing away unnecessary checks. And to do the low-hanging fruit. But I think what we can expect is that there will be few and minor improvements for security in 26. I fear that we won't see any significant progress until 29 at best, which means we are 5 to 6 years away from any real improvement. And that's at best. It could be 32. And according to Norwegian law, I could be retired by then. I would like to see something good happen before that point. They'll probably change the law before they change the language, so maybe that just works out. So why is this? Is the way the committee is organized hampering progress? Or do the problems just go too deep and wide to fix properly? I'm not an expert on this, but it frustrates me a bit. And does this constitute an existential crisis? Well, we have this combination of security threats that the language does not seem to be able to handle and respond to. We do not seem to be able to adapt fast enough. And the problems are deeply rooted and possibly unfixable. And this does not look sustainable long term. So, is C++ the new COBOL? Eventually, yes, I think so. But it will take time. But these security problems will drive the language towards obsolescence. They will be a big factor in that. And our inability to respond may accelerate this. And if people do not believe that the language can meet the challenge, they will eventually move away. So something to think about. C++ will be around for a long time, but these things will affect the demise of the language. It will accelerate it. So, if you want to go somewhere else, where would you go? This is easy stuff, though. There are some existing languages that you could have a look at. Some are partial fits. They don't fit all use cases, but they may fit some. And then, of course, the drop-in replacement. That will eventually always be mentioned when you talk about these things. Just a quick run-through. Go. It's garbage collected, which most of us are not big fans of because we are embedded developers, many of us. It's compiled, which is nice. It's memory safe when single-threaded, which is very nice. But data races are not memory safe, which is unfortunate because, threads are one of the things that Go is supposed to be good at. A bit slower than Rust and C++. It's Google owned, so you are at the mercy of Google in terms of its future. Also note that Google migrates much of its code to C++. No, from C++ to Rust, not to Go. Which is not because it's not a good language, but because much of the code they migrate, I suspect, is something that sort of needs C++, and Go is maybe not a perfect fit for that. Swift, I haven't used it personally. I've had a look, and it looks rather nice. Not garbage collected, but it uses reference counting and copy on write. It's memory safe. And then the really cool thing, in Swift 6, it's also thread safe, which is quite an achievement. So kudos to Apple on that. Really, really nice work. C++ interoperability seems to be good, but again, it's a proprietary language owned by Apple, so you are now at the mercy of Apple. Java, some might be surprised I even mentioned that, but it's memory safe. Data races are memory safe too, which is cool. If you have a data race, you can get an unexpected value, which is a bug, but it's still memory safe. It's reasonably efficient, but it is garbage collected. So not ideal for low-level system programming, but you can build embedded systems in Java if you just put some C or C++ underneath. It's been done. I've done it myself once. It was fun. Then there's Rust, memory safe, free from data races, good for low-level programming. Performance is good. It's fairly mature. Tooling is really great. And it's the only current drop-in replacement for C++. If you can use C++, you can typically use Rust as well. Some say it's a little harder to learn, and they talk about fighting the borrow checker and stuff. In my experience, C++ is also hard to learn well. We wouldn't have this big conference talking about all sorts of strange things if it wasn't. And if you're smart enough to learn C++, then you're probably smart enough to learn Rust. It's not harder. But we also have some interesting stuff going in terms of successor languages. So languages specifically designed to replace C++. A lot of cool stuff. CPP front by Hubsutter, Circle, Carbon, Hilo, probably more. So I thought about this, and I thought, well, what would the requirements be for something like that? And this is just something I came up with, so it's my personal ideas. Yours might differ. But these are the ones I came up with. It needs to be a cooler language than C++, or people won't use it. And it needs to be memory safe. And this is where it gets a bit serious. As far as I can see it, there is just no sane business case for switching to a successor language that is not memory safe. Why would anyone fund that in this day and age? It just doesn't make sense. So any successor language needs to be memory safe. So it means that any successor language that is not memory safe is just a hobby, basically. It will be dead on arrival. And it needs better C++ interoperability than Rust, because, otherwise just use Rust. It's available now. You don't have to wait for anything. So this one, CPP front, aims to be a better, safer language than C++. But so far, it does not seem to aim to be memory safe. So, it's cool, but I'm sorry. I don't believe in it. Circle, on the other hand, really interesting project. It's a single-man effort by a guy called Sean Baxter. It's probably the best Java application in history in terms of programming. It's a C++ compiler built on the LLVM backend with non-standard extras. And it's a memory-safe C++. You can have a look at this site. It's incredibly interesting. very, very impressive. He's just built a borrow checker, safer APIs, all sorts of language features. There's a demo out as well, which I recommend that you watch. It's really cool. And what he does is that he puts Rust-inspired features on top of C++. And this is just a small list. There's a lot more. All these features are put in not because they are cool, at least not just because they are cool. They are all necessary in order to achieve the memory safety in Circle. And also notice that there's a new standard library in this, because this is also required. The one we have is not memory safe. He doesn't show a complete new standard library, just the stuff he needs for the demo. So as a proof of concept. And there's a lot more features. He has a long list that you can have a look at. So how do you migrate from C++ using Circle? Well, safe and unsafe code lives side by side. And functions are either safe or unsafe, and there's a safe keyword to annotate them with. And safe functions can call safe functions, but safe functions do not call unsafe functions. That will break. Which means you can migrate incrementally. So, the interop is taken care of, which is cool. It's a nice solution. But the migrated code must pass the borrow checker. So if you find yourself fighting the borrow checker in Rust, you will find yourself fighting the borrow checker in Circle. But you get interop for free. But note that if you want to migrate to safe code, the borrow checker will require you to restructure your code, because that's part of what the borrow checker does. It does require you to structure your code in a certain way in order to pass the rules. So you're not just rewriting line by line, you are actually redesigning parts of your code. And you also need probably to rewrite for the new library. You can't use vector anymore. You have to use the 2 vector. So it's a bit of work. But I don't think it gets much easier than this. So where will this go? Can we bring it into the standard? Well, Sean Baxter estimates that this requires 300 pages of standards proposals, which is a lot. There's a great interview with him on the CPP cast podcast. I think it's episode 383, where Timo Dumle, one of the hosts, estimates that this will take 10 to 20 years of standard committee work. So, probably impossible. And I think the best way forward is probably that someone buys this and funds it and pushes it as a fork of something. I don't know. But it's a cool attempt. I wish him well. I hope he succeeds. Carbon, and if there are any Carbon people here and I say something wrong, just shout. Seems to have promising interoperability. Will be unsafe at first in 01. And then, as far as I could tell, they plan to introduce safety incrementally in 02. And it seems from the talk I've seen that safe carbon and unsafe carbon will coexist, which suggests a 2-step migration, that you migrate at scale to unsafe carbon using tool support, and then you migrate from unsafe carbon to safe carbon, which seems maybe to end up in the same terrain as Circle, this second point. And I also saw some suggestions that safe carbon will probably use a borrow checker. There aren't that many other solutions in town. There's a talk by Chandler Carruth from CPP Now, I believe, which goes into thread safety and, memory safety and carbon. So it goes a bit beyond the talk from yesterday on those topics, so it's worth a look. My fear is that the migration to safe carbon will be a bit expensive, because it's like with Circle, you need to restructure your code to pass the borrow checker, and you need to rewrite for new libraries. You can't call the old ones. They are not safe. There's UB everywhere. So there is a risk that, and this goes for Circle as well, there's a risk that a lot of code will stay unsafe. because your boss will not fund it, the final migration. And also, of course, as with Circle, if safety is opt-in, is it a memory-safe language? Opinions will differ on that. I've also noticed there's a new language called Hilo coming up, which seems to use mutable value semantics and might be easier to use than Rust. Maybe that will make it more restrictive. I'm not sure. I haven't looked closely enough yet. It looks interesting, but it's early days, and it seems to be slipping a bit versus the roadmap. They probably need more people working on it. But it could be a very, very interesting language. And we need to know more about interop. But OK, could be a contender. Should we wait for this? Well, I think that depends on your application. These languages are 5 years away at least. And new languages, the likelihood of success is not always that great. For many of us, they will arrive a little late, I think. If you're going to migrate eventually to something else, then maybe your best bet is to use an existing language instead of waiting 5 to 10 years for something that may not arrive. And during those 5 to 10 years, you will write a lot of new C++ code that you will also have to migrate later. So what to do? And why do we need to do anything at all? Well, some will say that our programmers make few mistakes. The problem is just that people use C++ wrong. Well, you've probably seen this before. All car drivers consider themselves better than average, almost all. And I think all programmers that are car drivers definitely consider themselves better than average. So, we tend to overestimate how well we can do things. Humans make mistakes, and Murphy's Law still applies. So I don't buy that one. Tools and discipline will get us safety. Use sanitizers. Use static analysis. Well, people are not disciplined. Not all the time. And we tend to opt out of security because we want to deliver software right now, and we have pressure to do so. And sanitizers only catch the errors that your tests trigger. The other ones go undetected. Static analysis, well, it usually works for single translation units. I'm sure there are tools that can do global analysis, but the ones most of us use, if we use anything, they do not do that. I've been trying to do this for more than a decade, and it's incredibly hard. It's not impossible. You can get close, but it's very, very difficult. It's not for everyone. So, safety is not important. We make stuff that's not critical. Lots of people have thought that and have been proven wrong. So what do we do? These are my personal recommendations. You can make your own. But I think we should consider not using C++ for new products. If you have the luxury of starting a new product, a new project, without having to relate to old C++ code, consider using something else. Maybe it's no longer the right tool for the job. We are engineers, and we should use the best tool for the job. And given today's security threats, well, it could be that this is not C++ anymore. And if C++ becomes the new COBOL, it's because of this. If you are making a new major component in an existing product, well, consider if you should do this in a new language. And if you're doing something where security is important, do a security analysis of your system. Find the attack surfaces, and consider rewriting those in a safe language. This is, I guess, to a big extent, what Google is doing. And this is really, in my guess, what the NSA and others want us to do. They don't expect us to go and rewrite everything. That's not going to happen. But they would like us to write as little new C++ code as possible, plain and simple. So, if you do migrate, are there some things you should think about? Well, yes. Interfacing your legacy code. Most languages support this, but usually through the C ABI. Some languages have good C++ interoperability as well. Swift seems to be good at this. Rust and Go has some support. The Rust support is improving, but it's hard. You can migrate gradually this way. Bottom up or component by component. This all depends on what your architecture looks like. And you need to take a close look and try to find opportunities in the architecture that you have. There are other things you could consider as well. You could put new code in separate processes. You could use some sort of communication infrastructure to communicate between the old code and the new. That will give you pure C++ processes and processes in new languages. This works especially well if you have message passing architectures, actor models, for example. And you could migrate one actor at a time, or one microservice, or what have you. Another thing you should think about is to try to start slow. This is change management, which is notoriously hard. You need to ensure support from key players in your organization. You need to have management behind you. You need to have the architects on board, and there will be other key players in your organization that do not have formal roles even that you need to convince. You also need to find a good candidate for migration. Something where migration will be a big improvement. And by good, I also mean likely to succeed, because you don't get 2 or 3 chances at this. You need to make this a success. And then you can build some momentum from that. Developers will enjoy this. So if you can make it a success and get people to see it as that, then they will talk about it to other developers, and things will start rolling. Just be a bit careful, because especially in the Rust community, there are people that are too enthusiastic. You know, they become almost like missionaries, like religious fundamentalists, and they do damage. You know, they drive people away. It becomes polarizing, and you don't want to go there, because that damage takes a while to repair. And because I don't do this often and tend to be a bit nervous, I do this in record time when I go on stage. So I finished this 10 minutes earlier than when I rehearsed. So any questions or opinions even? Yes?
You did not mention a language called SIG that is getting quite a lot of traction.
Right. You mentioned SIG. No, I did not mention SIG. It looks cool. I haven't looked very closely at it, because it's a successor language for C, right? Yeah. As far as I've heard, it has some memory safety issues, but it's probably not fully memory safe. Yeah. It's not a good fit for what I do. It might be a better fit for what you do. And if it improves the safety versus C, then yes, sure. Consider it. That's also a one-man effort, isn't it?
I think so. Yeah.
So hopefully he will get some more backing, because you need a community around this.
Actually, I think there are a few people working on it.
Right. So the ball is rolling. Yeah, absolutely. If it improves safety, then sure.
What languages are you in talks moving towards?
For the products that use C++, we are making a shift towards Rust. We have other languages as well, but yeah, we have new products and we have old products. We have big teams maintaining 30-year-old products, and of course, migrating that is difficult. Yeah. I'm sorry? We are using system on chip from several suppliers. Yeah.
But are you contributing back to like the NRF HAL or the embedded HAL projects? Are you involved with those organizations?
Contributing back is sometimes difficult for us because that might reveal information about products and libraries that we use. So for some products that can be difficult. But we would like to do it when we can. But we haven't done much of that yet, unfortunately. It's a little difficult, yes.
There is an effort going on currently for making the Zephyr RTOS compatible with Rust.
Ah.
Is that something that you are actively looking at?
No, not that specifically. But that would be cool. Yeah. We tend to have to choose operating systems also based on what sort of platform it runs on. So we're not free to choose anything we want, of course. Yes? Anything else? No?
Normal C, will that still exist, or?
Yeah, that's a good question. I went to a talk by Robert Secord about 2 years ago, and he presented himself as, a standard committee guy, and said that they plan to outlive C++. And I think he's right. I think they will. C++ has a niche that will probably always exist, not just because of Linux, but it's the language of choice for board support packages and example programs for microcontrollers and that sort of thing. And you need an easily accessible language for that. So I think that's something that, there will always be C, I think.
What is your thought for the so-called C++ for .NET?
You mean this what did they used to call that? I wrote some code in that once, I think. You run it on the virtual machine, if you like, yeah. Wasn't that something Microsoft did for interfacing purposes mostly? Is it safer? I don't know. I don't know much about that. Sorry. Yes?
You said that you're moving Rust for your C++ code. What are you using for it?
Right. At the moment, we are running the Rust code as a separate process, or several, actually. And then we use communication mechanisms to talk with it. It was easier for us. We had the infrastructure in place to do that easily. That worked well. Yes?
You mentioned using messaging protocols. I saw you mentioned gRPC. Have you tried using that also in Go world?
Actually,
In Java world, it was kind of.
okay. You asked if we had used gRPC. I haven't used that myself. I mentioned it because it's so common and well tested. We are not using that ourselves. There are others. There's a lot of stuff you can use. So find the one that suits you. But you will want one that is good for the language you have and the language you're moving to. So you have to test before you invest money in that. Yeah.
I find that gRPC is easier to work with than, let's say, SOAP. Because SOAP
Yeah, you don't want to use SOAP now. There are better things available. Okay. Any last questions? No? Okay. Well, thank you for listening.